Hello, today we're going to talk about giving examples of functions that are not linear. A linear equation can be written as y equals mx plus b, where b is your y-intercept and m is your slope. If you want to write it as a function, you just switch the y to the f of x. All right, what this makes is a straight line. All right, whether it's positive or negative or zero. All right, now if you're not talking about function, you're just talking about a linear. You also have this. This is not a function, but this is x equals whatever. This can be y equals whatever. All right, so it depends on what it is, but they are all straight lines when you have a linear. So this is giving examples of functions that are not linear. So any function that's written as, let's say, y equals 2x minus 4, or y equals 3x plus 5, or y equals 1/2 x, just like that. Those are all examples of linear functions. Or I shouldn't say functions. Those are all linear equations. I hate saying functions with the f of x there. Makes me very angry for some reason. There you go. Those are all linear functions. All right. Now you could, if you want to switch this to y, it's fine, because f of x is the same thing as y. So it doesn't matter which one you put. I just like when I talk about functions that have f of x there. So those are all linear. They all have a slope and a y-intercept. This y-intercept here is 0. I could also do y equals 5. My slope is just 0 there. All right, there's no exponents, there's nothing crazy with it. Right? So these are all linear. These are examples of linears, functions, linears, straight lines. Not curved lines, straight lines. All right, examples of non-linear functions. So if any linear function is some sort of straight line with no breaks, I'm going to erase that because that's not a function. Let's talk about functions. So it's written in the form y equals mx plus b. So any nonlinear function, or any linear function is going to be in this form. Any nonlinear function is going to look different. So if I have y equals 2x squared. All right, now let's see what this looks like just for the fun of it. So if I do -2, that gives me 4, 8. -1 gives me 2, 0 gives me 0. 1 gives me 2, and I'll do 2 gives me 4, 8. So if I graph this, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, so 2, 8. 1, 2, 0, 0. 1, 2 right there, and 2, 8. It gives me what is known as a parabola, because this is a quadratic. A quadratic is squared. So there you go. Is that a straight line? No, it is a curved line. So this is non-linear. Anything with an exponent greater than 1, so 2x squared or 3x to the 5th plus 5, or f of x equals negative x to the 4th plus 2, or f of x equals negative x to the 100th plus x to the 4th plus 6. Those are all nonlinears because they have exponents. Anything that has an exponent, even if the exponent is a variable, so 2 raised to the x, or 5 raised to the y, those are called exponentials. All right, anything that has an exponent is anything that is a power raised to something. All right, anytime that happens, they're non-linear. You can go ahead and graph them if you want, but they're going to show up something like this or a little bit different. These are all non-linear. All right, so I showed you one graph, I showed you examples. Let me show you some more graphs of non-linears. So, all right, is that linear? Absolutely not. That is not linear because it is not a straight line. Or what about this? Is that linear? No, it is not a perfectly straight line. It has a break and it stops. Those are non-linear graphs. All right, this has been a real short video over giving examples of functions that are not linear. Hope it helps.